In the previous slides, we focus on natural factors and processes. However, as noted in the beginning, man-made activities and uses within the coastal zone significantly affect coastal processes that result to coastal erosion and coastal degradation. Some of these man-made interventions are dams, sand extractions, coastal constructions, and touristic facilities. As you know, a large variety of activities are hosted in the coastal zone which support the economy and serve many needs. As a result, often environmental problems occur that cause deterioration of citizens' lives. Deltaic coastal areas are constantly evolving as a result of the interaction of terrestrial, river discharge, coastal morphology, and marine processes such as waves, coastal currents, and tides. In fact, the construction of dams has led to a drastic reduction of sediment volumes reaching the estuaries globally at percentages ranging between 10 and 90%. Although the contemporary sea level rise contributes to the loss of many deltas globally, the degradation of wetlands is related to man-made interventions. So, what are dams? They are constructions designed to store and divert water. They change the natural physical distribution and synchronization of river flows in order to serve human needs. Dams are a significant human intervention to the balance of an area, and their usefulness and overall design has been a major subject of discussion in recent years. In order to minimize the environmental and other impacts and losses, better planning of dams is needed. Cultural, social, humanitarian and environmental values should be taken into account in the planning, design and construction of these large constructions, and their evaluation should go beyond the inclusion of traditional economic values. Some of the environmental changes are mentioned next. The functioning of a dam alters the supply of the river downstream with significant effects on local hydrology, downstream water and sediment transport. In river deltas, it is possible to cause a shoreline shift of about 5 to 10 meters per year, resulting to erosion and alteration of the local ecosystem. The fauna downstream is negatively affected due to the changes in river flow as well as possible changes in water temperature, salinity and oxygen. The microclimate of the area may also be disturbed due to the changes in water regime, causing changes in moisture content, air temperature, air movements and changes in the local topography. At the same time, the development of a reservoir can cover places of historical interest, geological or aesthetic value. In the two photographs, you may see the erosion of the coastal zone at Marathonas area, Eastern Attica, due to the construction of a dam upstream. One important human intervention is sand extraction. Extensive sand extraction has played a crucial role in Greek coastlines since 1950s. The sand of Greek coast has very good physical properties for building constructions, consisting of fine-grained material. In Greece, sand extraction constitutes a source of easy and quick profit for many constructors. As a result, large quantities of sand from several coasts were extracted and transported. In many occasions, illegal sand was taken from isolated beaches in order to avoid the high cost of marine sand. Sand extraction was declared illegal in 1986. Today, this law is enforced to a few coasts. Another significant man-made intervention are construction projects. They are usually installed on the natural shoreline, resulting to the development of a new artificial coastline with different geomorphological and sedimentological features. For instance, the infillings that usually accompany harbor works, such as piers and breakwaters, in addition to aesthetic pollution, often cause changes in the coastal currents. The design and implementation of a technical project requires a multidisciplinary approach. There is need for collaboration of engineers and oceanographers in order to maximize project efficiency and minimize environmental impacts. On many occasions, construction projects are not designed appropriately, causing problems to the environment and the construction itself. For example, the sediment budget may be altered, causing areas of erosion and areas of deposition. It is not uncommon that sometimes even harbor works are covered by sediments as a result of this balance alteration. Example of a coastal erosion which is nowadays affecting even the road network. Examples of breakwaters in the coastal zone of Marathon, Eastern Attica. In the area, there is a current transporting sediment towards the west. They had built the breakwater at the left photo first, and afterwards they built an artificial channel for flood events. Afterwards, they built the second breakwater in the right photo in order to keep the channel open. Last but not the least, touristic facilities greatly affect the coastal zone and coastal erosion processes. In fact, in many cases, uncontrolled and unregulated constructions, such as buildings, are an important factor for the degradation of the coastal zone. Because the touristic sector has developed as an occupation, in many coastal areas, agriculture was abandoned, and as a consequence, the soil was hardened and became more difficult to be transported to the sea. Coasts are no longer supplied from the land, and coastal erosion is active. This phenomenon is further intensified due to climatic change and the intensity of storms and waves. Note in the upper photos the intensity of coastal erosion within a year. In Marathon area, a number of houses and touristic places such as taverns are now eroded. Examples of eroded coasts. On many occasions, they build small walls to protect the coastal road from erosion, but the phenomenon is so intense that causes even the walls to collapse. Taking all the aforementioned into account, how can we evaluate coastal erosion in a particular area? Through the study of historical maps, aerial photographs, satellite images, drones, etc., we may compare the evolution of a particular area and estimate the retreat rate of a coastline. In the next slides, we will discuss how we deal with coastal erosion. A number of activities and uses take place in the coastal zone, as you may see on the slide. For these reasons, the coastal zone is often heavily populated. In this slide, you may see the coastal erosion pattern of European countries. The Mediterranean coasts have the higher values, as you may see on the diagram on the right. So, what can we do? During the last century, most protection works were related with hard engineering, which relates with the use of timber, rocks, or concrete constructions on the coastal zone. In contrast with hard engineering, where typically has no habitat value for fish or wildlife, soft engineering incorporates both of them. Soft engineering is related with the use of ecological principles and practices to reduce erosion and achieve the stabilization and safety of shorelines and the areas surrounding rivers, while enhancing habitat, improving aesthetics, and saving money. Soft engineering is achieved by using vegetation and other materials to soften the land-water interface and improving ecological features without compromising the engineered integrity of shoreline or river edges. Nourishment is a process by which sediment, usually sand, lost through longshore drift or erosion, is replaced from sources outside the eroding beach. Nourishment is typically a repetitive process since it does not remove the physical forces that cause erosion but simply mitigates their effects. The advantages of beach nourishment are that it widens the recreational beach and the structures behind the beach are protected as long as the added sand remains. Some disadvantages may be that beach nourishment sand may erode. It is expensive and must be repeated periodically. The beach turns into a construction zone during nourishment. The process of nourishment may damage, destroy, or otherwise hurt marine and beach life by burying it. And also, the sand added to the beach is often different from the natural beach sand. It can be very hard to find the perfect match. Sand dunes are unique among coastal landforms as they are formed by wind rather than moving waters. They are a store of sand above the landward limits of normal high tides, where their vegetation is not dependent on the inundation of seawater for stability. They provide an ideal coastal defense system. Vegetation is vital for the survival of dunes because their root systems bind sediment and facilitate the build-up of dune sediment. In dune building or reconstruction, sand fences and mesh matting in combination with planting vegetation have successfully regenerated dunes through sediment entrapment and vegetation colonization. The vegetation used should be governed by species already present in the area. Based on studies and scientific results, the presence of vegetation in coastal areas improves slope stability, consolidates sediment, and reduces wave energy moving onshore. Therefore, it protects the shoreline from erosion. In some cases, revegetation fails because environmental conditions do not favor the growth of species at the particular site, or there is ignorance as how to plant properly given the same conditions. It is also possible that anthropogenic influences have completely altered the natural processes in the area. The most obvious indicator of the site's suitability is the presence of vegetation already growing. This can be extended by other factors such as the slope, elevation, tidal range, salinity, substrate, and hydrology.